Happy Monday. So as I promised last time, I'm going to show you a random forest algorithm, which is an extension of a regular decision tree algorithm. We're going to first using the National Household Travel Survey as the example to show a 25 tree algorithm as a forest, and then we're gonna put it in a loop to run from one tree to all the way to 24 trees or 25 trees, and to see the relatively the optimal size of the random forest that can fit the model pretty well, so that later we can use particular number of forest to fit in the bigger data with the relatively efficient running time. So let's look at the regular random forest first. It's very similar to a regular decision tree algorithm. We import all those packages from the Python, and then we're gonna change the directory to the directory with all those data. I'm gonna import all those data, clean the data, and then we're gonna set a predictor and a target but here we only extract a few features or attributes. Actually, we can import more. Here is only a demonstration, so it's pretty. I only imported several. I think that is important. And for the target, I'm gonna still set it as a working number, the workers number in the household, but because we were trying to figure out the average number of the commuting trips, work-based commuting trips, from each household to and before, so that we can kind of. In this particular example, I'm trying to understand the relative demand of using ride sharing, such as Uber or Lyft, particularly for work-based travel, because those trips are usually regular and predictable, and relatively longer, and require a higher reliability or lower uncertainty or lower risk. So I think a particular studying in this particular type of trips may be helpful for improving the ride sharing service as a whole. So just like before, a little bit different here is that I set it as 40 to 60% split rather than 30-70%. It's because I want to test a little bit more and to be more confident in terms of the way we set the categories or the questions. And here, what's a little bit different is that we use a ensemble model from the random forest classifier, and we set the number of azimuth as the 25, so that means there are going to be 25 trees in our forest, and then we're going to set it to predict we use the test data to feed into the classifier. We just specifically estimated. And then we're gonna set compare the prediction with the actual result in the test target data, and put it into the confusion matrix, and then we can use the actual trees classifier method, and to build a model object, and then we feed the data into the model object, and then we can display the relatively important attributes. Let me first show you the confusion matrix. And you see it's actually not getting too much better than the the decision tree that we just used in the previous video. That's probably because the specification of my features, and also like I think it's good lessons like we can learn from it is that random forestry is not necessarily better, okay? But it may be, but usually it gives us more reliable answer, and we can understand better of our specific individual tree in the forest. And we can also print the model feature importance. So we can see that the first feature is relatively the most important one, which is the drive count thing. Let me check my code book. So it's dr. Let me try the dr right here, which is the number of drivers in the household. Okay. So this is the most important features that in our forest, and the way that the forest works is that every time we import a testing data or forecasting data, as the forecasters, the random forest will vote from each tree and to see the importance of this feature. Okay, and with this algorithm, we can actually fit into a loop, so that, which is here. All the rest is almost the same. So we specify the tree, and we making the loop, and set the n estimators from 1 to 25, and we test the improvement, and we can see from 0 to 25. It's more like a logarithmic improvement. So probably if we feed the data, if we feed the line here, probably we just need a forest with size less than 5. Probably somewhere here will be good enough, because if we increase it, we'll significantly improve our increase our computational time, but the accuracy is actually not getting too much better. Okay, and so here is our random forest algorithm, and thanks for watching. See you next time.